Hello everyone to the assumptions of multiple linear regression. The first assumption is linearity. So what is linearity? Linearity means the relationship between the independent variables and the dependent variable need to be linear. So if you look at this diagram, you see you can draw a line that fit most of these data points. So overall, the data looks like is a line, and this is the best way to test the linearity of your data. And this is an example for not linearity. In the first diagram, the data is almost like a curve. You cannot draw a line. So linearity here is not existing. And also in the second diagram here, data is scattered randomly. So there is no way to draw a line here, neither here. But if you go back to the previous diagram, you see that the data is almost like a line. So this is the first assumption. The second assumption here in multiple linear regression is multivariate normality. So what is the meaning of that? That means the data that we are using to build our multiple linear regression should be normally distributed. And normal distribution is one of the statistical distributions. We assume that when we collect data to build our linear regression, we assume that these data should follow the normal distribution. When you draw your data here, like if you put your data as a histogram, you can draw bell. So also we call this type of distribution or this kind of distribution the bell distribution because it has the shape of the bell. So the data start with low values in one of the sides and get higher in the middle and again get lower on the other side. And that's why it has the bell shape. And this is an example for a perfect bell distribution because the data here are getting higher gradually until reach the highest in the middle and again gradually are getting lower. And this is the example for the perfect one. And usually data are not perfectly normally distributed. And the bell shape could be different from data to data. Sometimes the data has a long tail. When the data are shifted to the one of the direction, right or left. So in this example, in this diagram, most of the data here are located to the right. So that's why in this normal distribution, we have a tail to the right. And the vice versa, when most of the data are low, so in this case, you will find the tail to the left. And also, the bell can be narrow or wide based on the standard deviation or variance in the data. When the standard deviation is high, you expect to see this wide bell because data are scattered further from the mean. And when the variance or standard deviation is low, the data are scattered closer to the mean. So we will find this blue bell narrow. So we got this dot line bell when we have a high standard deviation and this tight or narrow bell when we have low standard deviation. So this is the second assumption in multiple linear regression. Data should follow the normal distribution, or we call it multivariate normality. And if you look at these two diagrams, you find this data is not perfectly follow the normal distribution. You see that some data here on the left is high, then again get here low and high and low. And when we usually have this problem, sometimes we use some techniques to solve this problem by either collecting more data, and the more data that we collect, the closer will be to the normal distribution. Or there is another way, we call it non-linear transformation, and that might fix this issue. And the next assumption is no or little multicollinearity. Multicollinearity occurs when the independent variables are too highly correlated with each other. So let's take this example. We want to predict the price of a car, and we got three independent variables: the car model X1, year X2, mileage X3. The assumption here, we should not have strong correlation or relationship between some of these independent variables, such as between the year and the mileage. And in some cases, the year and the mileage are highly correlated, because the more years that you have in your car, the more mileage you will drive. So this should be considered when we build a multiple linear regression to predict the price of the car. And multicollinearity may be tested using the correlation matrix. The correlation coefficients need to be smaller than 1. And we have 3 levels of correlation. When the correlation is equal 1, this is 100% correlation. These two variables are 100% correlated with each other. And usually, when we need to test that, any correlation is greater than half or 0.5 is considered high and can badly affect the regression accuracy. Anything less than 3 might be acceptable, and it is different from case to case based on our business scenario. And the other assumption here is no autocorrelation between residuals. The autocorrelation occurs when the residuals are not independent from each other. When we draw slope line of the regression, some points are not fit on the line. So we assume here, based on that, autocorrelation occurs when the residuals are not independent from each other. So we assume in multiple linear regression that there is no autocorrelation between these residuals. Homoscedasticity. Homoscedasticity means the residuals are equal across the regression line. So if we draw our slope line here over the data points, we can draw also 2 parallel lines. One is upper to the slope line of the regression and the other one is lower. And all of these 3 lines should be parallel. In other words, if we draw any vertical line from the slope line up or down in any point, these vertical lines should be equal. And this is an example for data is not homoscedastic, or we call it heteroscedastic. The upper and the lower lines are not parallel. The further they go from the y-axis, they are going wider. So if we draw a vertical line here, we'll find it like shorter than the vertical line here. And this one is shorter than that. And these are all the assumptions of multiple linear regression that should be considered when we create a multiple linear regression to be considered a good model that can predict our target data.